This is SpaceTime Series 24, Episode 55. Coming up on SpaceTime, have astronomers found antimatter stars? Ingenuity and Perseverance head south as they begin their exploration campaign on Mars. And SpaceX successfully launches the same Falcon 9 rocket for a 10th time. And Elon Musk says they'll continue pushing the envelope. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified 14 potential candidate stars that just maybe might be made out of antimatter rather than normal matter. One of the biggest problems with science's understanding of the universe and cosmology is that equal amounts of matter and antimatter would have been created in the Big Bang when the universe came into being 13.82 billion years ago. Now, other than in science fiction, there's really nothing special about antimatter. It simply has the opposite electrical charge of so-called normal matter. So, the antimatter counterpart to the positively charged proton is the negatively charged antiproton, and the antimatter counterpart to the negatively charged electron is the positively charged positron. The problem is that when matter and antimatter come into contact, they annihilate each other. So, with equal amounts of matter and antimatter being created in the Big Bang, the universe should have annihilated itself in a bright blue flash of gamma rays as soon as it came into existence. Yet, clearly, that didn't happen, and we live in a universe composed mostly of matter rather than antimatter. Of course, that doesn't mean there isn't any antimatter out there. We see it all the time, it just doesn't hang around very long. And there may be significant regions of antimatter in the observable universe, but so far we haven't found them. Finding huge regions of antimatter would require looking for the high-energy gamma-ray glow being generated on its borders, where matter and antimatter come into contact. This annihilation radiation would feature a characteristic spectrum, peaking around half the mass of a neutral pion with a cutoff around the mass of a proton. But the failure to detect this annihilation gamma-ray radiation has virtually excluded the existence of at least significant amounts of baryonic antimatter in our cosmic neighbourhood. However, the Alpha Magnetic Spectrometer experiment AMS-2 aboard the International Space Station has on several occasions tentatively detected anti-helium nuclei. Not many, but somewhere around 1 in every 100 million helium atoms. Now, of the events that have been reported, 6 are compatible with being anti-helium-3 and 2 with anti-helium-4. So that raises the question about whether this represents a sort of smoking gun for the existence of antimatter stars or anti-stars, and possibly even antimatter galaxies. To try and resolve the question, astronomers have turned to NASA's Fermi Gamma Ray Space Telescope, again looking for that telltale annihilation radiation. The authors analysed data from a gamma-ray catalogue known as 4FGL-DR2. Now, 4FGL-DR2 is based on 10 years of observations looking at the 50 megaelectron volts to 1 teraelectron volt energy range. It contains some 5,787 gamma-ray sources, including their spectral parameters, spectral energy distributions, light curves, and multi-wavelength associations. Reporting in the journal Physical Review D, the authors were able to identify 14, possibly stars, whose properties were spectrally compatible with the type of signal likely to be generated by matter-antimatter annihilation. Now, the authors stress this doesn't mean they've found a bunch of antimatter stars. These things are just as likely to simply be pulsars or stellar mass black holes. Still, if they were antimatter stars or anti-stars, you could extrapolate that out to indicate the Milky Way contains as many as 5 antimatter stars for every 2 million regular stars. And the authors say that to be the source of the annihilation nuclei tentatively detected by the AMS-2 experiment, these anti-stars, if they do really exist, were probably between around 30 and 1,000 light-years away, which means they could be hiding in the galaxy's disk or, at most, in the galaxy's halo. It's certainly not proof of antimatter stars. But you've got to admit, it does deserve further investigation. This is SpaceTime. Still to come, NASA's Ingenuity and Perseverance head south on the Red Planet as they begin their scientific mission. And astronomers have created a three-dimensional map of magnetic fields in a small wedge of the Milky Way galaxy. All that and much more still to come on SpaceTime. NASA's Ingenuity helicopter has completed its first one-way flight above the surface of the Red Planet, landing at a remote location 129 metres south of its takeoff point. Ever since Ingenuity arrived on Mars in mid-February, tucked beneath the Perseverance rover, the tissue box-sized twin-rotor aircraft has never ventured far from home base, an area which has been dubbed Wright Brothers Field in honour of Orville and Wilbur Wright, who undertook the first powered controlled flight in history. And after each of Ingenuity's 4 test flights, it's always returned to the same spot each night. Now, with these test flights completed, proving to mission managers that the 1.8 kilogram autonomous helicopter really can fly in the Martian atmosphere, its 5th flight transitions the rotorcraft into a new role, one of supporting Perseverance in its mission to study the geology of the River Delta region of Jezero Crater and search for signs of past microbial life on Mars. The 108-second flight took Ingenuity south, climbing to an altitude of 10 metres and surveying the surrounding terrain, taking high-resolution colour images of the area before touching down at the new site for its first overnight stay away from Wright Brothers Field. The Ingenuity team at NASA's Jet Propulsion Laboratory in Pasadena, California chose the new site based on information gathered during the previous flight, the first aerial scout mission on another world. That flight generated digital elevation maps indicating almost completely flat terrain, with virtually no major obstructions. The flight represents the rotorcraft's transition to its new operations demonstration phase, focusing on the type of capabilities a rotorcraft operating on Mars can provide, such as scouting ahead for the best terrain, undertaking aerial observations of areas not accessible by a rover, and of course detailed aerial imaging. These operations and the lessons learned from them will significantly benefit future aerial exploration of Mars and other worlds, including the upcoming Dragonfly mission to the Saturnian moon Titan. Of course, this new phase also brings with it added risk to Ingenuity, with more one-way flights and more precision manoeuvring required by the autonomous aircraft. Having successfully landed at its new site, Ingenuity will now await future instructions relayed by way of the Perseverance rover from mission managers. Meanwhile, the 6-wheeled car-sized Perseverance is also heading south towards its first primary science and sample collection spot, not far from where the helicopter's sitting. The rover team's near-term strategy won't require any long drives that would leave the helicopter far behind, thereby allowing Ingenuity to continue supporting the primary mission as they move together through new terrain. But for the media back home on Earth, some 317 million kilometres or 18 light minutes away, the highlight of the past week has been the ability to actually hear the sounds of Ingenuity's whirling rotor blades cutting through the thin Martian atmosphere. The sound of human encroachment on the surface of another world. The initial rumble in the background is the Martian wind, while the hum which takes over are the helicopter's blades spinning at 2,537 RPM, with the sound being greatly muffled by the thin Martian atmosphere. Perseverance used one of its 2 microphones to listen as the Ingenuity helicopter, some 80 metres away, flew out on its 4th mission back on the last day of April. It's the first time a spacecraft on another planet has recorded the sounds of another spacecraft on that world. This is SpaceTime. Still to come, astronomers create a 3-dimensional magnetic field map of part of the Milky Way galaxy. And SpaceX reaches a major milestone, successfully launching the same Falcon 9 rocket for a 10th time. All that and more still to come on SpaceTime. Astronomers have created a three-dimensional map of the magnetic field in a small wedge of the Milky Way galaxy. The research, reported in the Astrophysical Journal, paves the way for discoveries improving science's understanding of the evolution of the Milky Way, the formation of stars and planets, and the early stages of the universe. Lead researcher Dr. Aries from Australian National University says the work was the first to tomographically measure the strength of our galaxy's magnetic field. The Milky Way's magnetic field and cosmic dust act like a veil that obscures the radiation from the early stages of the universe known as the cosmic microwave background. And it's prevented scientists from testing cosmological models for the universe's evolution. Tritzer says the research provides a means to map the strength of the magnetic field for all regions of our galaxy, enabling astronomers to better understand the universe's evolution. The authors found that the galaxy's magnetic field strength was much higher than previously thought. Most models that predict the strength of the galaxy's magnetic field for every location and distance from the Sun are based on observations that can't probe the magnetic field in 3 dimensions. The study is also an important step in understanding how ultra-high-energy cosmic rays travel through the galaxy. Galactic cosmic rays are very high-energy particles, often with energies far greater than what can be produced in even the biggest particle accelerators on Earth. Tritzer says that by understanding the structure and strength of the magnetic field, astronomers can improve their chances of finding the locations of the sources of these extremely energetic particles and thereby probe new physics at extreme energies.
The magnetic field plays an important role in many astrophysical processes. The importance is more or less threefold. So first, you have cosmic rays, which are very energetic particles, some with energies much more than what we can reach with our accelerators, right? And because these particles are charged, they are deflected from the magnetic field.
Why is it important to know how cosmic rays are deflected by magnetic fields?
We want to know their sources. And second, we want to know their nature, how heavy these particles are, in a sense, right? And as a result, we can test our models of particle physics in very, very high energy.
And by that, you find out more about the properties of cosmic rays as well as where they're coming from.
Yes, exactly.
And of course, that's not the only issue, is it? Also, we want to find out more about the cosmic microwave background radiation, 2.7 degrees above absolute zero now. It's often described as the leftover light from the Big Bang itself, some 380,000 years after the Big Bang occurred.
Exactly. And the thing is that all over our galaxy, there are some dust grains. And these dust grains are lined with the magnetic field, and they act sort of like a veil that prevents us from studying all the properties of the CMB. And some properties that we haven't yet studied hold important clues about these early stages of the universe.
Does this include things like the Hubble constant? Because there are different ideas as to what the Hubble constant actually is. There are 2 primary ways of looking at the Hubble constant, and they're giving different figures.
Yes.
One of those ways is
Yes.
the CMB.
Right. So it's not directly related to that in the sense that some theoretical cosmological models predict from inflation. So inflation was a period of the universe where the universe grew exponentially, right?
Mm-hmm.
And so some of these theoretical models predict a certain pattern to be present in the CMB. And once we confirm that, we can determine, in a sense, the Hubble constant. But the magnetic field and the dust grains are in the way.
And understanding cosmic inflation would tell us all about, well, the moments of the Big Bang itself.
Yes, exactly.
Which is about as far back as you can see.
As far as you said it right, yes. The magnetic field is very, very important for the evolution of molecular clouds, which are the places where stars are formed. So a 3D map of the magnetic field of the galaxy will just give us really important information regarding star and planet formation.
So we'll find out more about where we came from.
Yeah. So we'll actually find where the universe came from, where we came from, what's happening in the most energetic corners of our cosmos. We'll learn a lot of things. It's just the magnetic field is standing in the way.
It's funny, isn't it, when you think about it, because astronomers haven't really focused as much on the magnetic field as they should have over time. They've always looked at just the optical light, but they haven't looked at the other side of the electromagnetic spectrum, the magnetic field, to nearly the same degree.
The thing is that it's very, very hard to observe, and especially in 3 dimensions. So there was a saying, one would observe certain phenomena and investigated what part of the phenomena could be explained. And then the unexplained part was taken to show the effect of the magnetic field. So the largest one is ignorance, the stronger the magnetic field.
I've heard that expression myself, yes.
Yeah.
So how were you able to map the magnetic field?
Okay, so the way we did that is by examining the clouds threaded by the magnetic field. And there are some magnetic waves, right? And these waves leave their imprint in the clouds. So by studying the clouds, we study these magnetic waves, and by studying these magnetic waves, we can find the value of the magnetic field. And the cool thing is that we can do that in 3 dimensions, which has never been done before. And we now have a method to map the magnetic field in 3D, so out of the 2-dimensional world and into the full 3D.
What did you use? What instruments were used to do that?
So I used some observations, some radio observations, looking at H1, the neutral hydrogen.
Any specific telescopes or just whatever archival?
There were many surveys, so there were a couple of surveys the past decade, a compilation of observations called H1 for Pi.
And where to now? You want to increase that map, I take it?
Yeah, so our next plan is to increase that map and do the entire galaxy and have a view of the magnetic field of our entire galaxy, which would be hugely important.
Why did you choose the 2 slices of the pie you chose? Were there any particular reasons for that, or is there something in that direction those directions you're interested in?
Yes, actually there was. And so in that general direction, we also observe the so-called cosmic ray hotspot, which is basically an excess of ultra-high energy cosmic rays on the sky.
What's located in that direction?
The direction was towards Ursa Major.
So that's where we think the cosmic rays are coming from, or some of them?
We don't know, because the fact that we see them projected on the sky towards that direction doesn't necessarily mean that they're coming from, let's say, a galaxy right behind that region in the sky, because of the deflection from the magnetic field.
Is there anything in that direction that is likely to generate them? I mean, specifically extra large supermassive black holes or anything like that?
We're looking into that. We're not sure yet.
Time will tell.
Time will tell, yes, exactly.
That's Dr. Aries from the Australian National University. And this is SpaceTime. Still to come, a major milestone for SpaceX as they launch the same Falcon 9 rocket for the 10th time. And later in the science report, fission reactions discovered smouldering away in the wreckage of the Chernobyl nuclear power plant. All that and much more still to come on SpaceTime. SpaceX has passed a major milestone, carrying out a successful 10th flight using the same Falcon 9 first-stage booster. The booster, numbered B1051, was used to launch the 27th cluster of 60 Starlink broadband telecommunications satellites. The mission was flown from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. After MECO, or main engine cutout, and stage separation, the booster successfully returned to Earth, landing on the drone ship Just Read the Instructions, which was pre-positioned 630 kilometers downrange in the North Atlantic Ocean. SpaceX originally designed the Block 5 version of the Falcon 9 first stage for 10 launches, but they're now considering extending that as pre-flown rockets all appear to be doing well. The company says it's using its internal Starlink missions to test the limits of the booster's reliability. As for this booster, B1051, it's only required minor refurbishment between each flight. SpaceX boss Elon Musk says there's been no significant wear and tear of any of the major components, meaning that with engine replacement, each booster could theoretically fly up to 100 times. B-1051 first flew back in 2019, launching the unmanned Crew Dragon capsule on the Demo 1 mission to the International Space Station. It's also launched a trio of Canadian Earth observation satellites, a SiriusXM broadband telecommunications satellite, and 7 different Starlink missions. SpaceX are so confident with the reliability of their boosters, they're now equipping the 70-metre tall rockets with a series of upgrades, including more robust thermal protection systems, a more durable interstage, that's the bit between the top of the core stage and the upper stage. They're improving the titanium grid fins used to control the boosters during their re-entry into Earth's atmosphere, and they're being given more powerful engines. Last year, SpaceX also positioned both of their drone ships, Of Course I Still Love You and Just Read the Instructions, on the East Coast, thereby allowing launch frequencies to be increased to less than a week between flights. In fact, this latest 27th Starlink mission launched just 5 days after the last. And like the last, the 60 satellites on board this mission were all safely deployed into a 580-kilometre high orbit. For the record, the total number of Starlink satellites now launched stands at 1,625, of which 1,554 of the 260-gram spacecraft are still in orbit. SpaceX is hoping to eventually launch over 30,000 Starlink satellites, providing broadband internet coverage over much of the planet. This mission was also the 14th Falcon 9 launch so far this year. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Increased levels of neutrons emanating from an inaccessible basement area at the Chernobyl nuclear power station indicate that fission reactions are again smouldering away at the site. The number 4 reactor at the Chernobyl nuclear power plant in the Ukraine exploded during a failed test in 1986 in what's become known as the world's worst nuclear disaster. Now, a report in the journal Science claims new readings are showing that radioactive neutron emissions have increased by 40% since 2016. And that suggests a growing fission reaction is underway deep inside the wreckage of the plant. The focus of attention is the mangled reactor hall basement, known as Room 3052. It's entombed deep under hundreds of tons of highly radioactive steel and concrete rubble, and it contains a congealed mixture of highly radioactive melted lava, including about 170 tons or 95% of the number 4 reactor's uranium fuel load, as well as the fuel rod zirconium cladding, the graphite control rods, and hundreds of tons of sand and concrete, which was dumped onto the core to try and extinguish the fire. The deadly black molten lava mixture that's resulted slowly oozed into the basement after the meltdown. Computer modelling suggests that neutrons in the lava are splitting uranium nuclei, causing fission to take place. The spectre of self-sustaining fission or criticality in this highly radioactive ruin has long haunted scientists. So what's gone on? Well, it's thought the giant sarcophagus hurriedly constructed over the reactor site after the explosion was riddled with holes allowing water to seep in, and that water moderated neutron reactions in the uranium lava. However, a far more massive concrete and steel encasement has now entombed the entire number 4 reactor site, and that's prevented further water seepage. And with the water level in the basement dropping, there's nothing to sufficiently slow the neutrons down. And it's that which they fear is causing the increases in radiation. On the other hand, once the water dries up completely, the neutrons will be moving too fast to be captured, and that should prevent fission from occurring. For now, however, the radiation continues to seep out and levels continue to increase. Now, it's important to point out that there's no chance of a repeat of the 1986 explosion, which sent a radioactive cloud over much of Europe. However, there are concerns that the fission reaction now underway in the wreckage will accelerate exponentially, and that could lead to a smaller uncontrolled explosive reaction, which could bring down unstable structures inside the sarcophagus, spreading a massive cloud of radioactive dust. Scientists are looking at a couple of possible solutions. One would involve drilling into the basement, and then spraying the entire area with a neutron absorber such as gadolinium. Another option would involve developing a robotic drill capable of withstanding the intense radiation long enough to drill directly into the lava itself and insert a series of boron control rods in order to restrict the neutron's activities. Whatever happens, for now and for the foreseeable future, the number 4 reactor site at Chernobyl will remain the deadliest place on Earth. As the horrific COVID-19 death toll and infection rate continues to spiral across India, scientists are working to try and understand the coronavirus variants now circulating across the subcontinent. The country is recording some 400,000 new infections every day, taking the total from this ferocious latest wave to more than 22 million. A report in the journal Nature claims there's growing evidence that a new variant, known as B1617, which was first detected in India, might be more transmissible and better at evading immunity than other variants. The studies are also suggesting that this Indian variant might be causing more severe disease. Almost 3.5 million people have now been killed by the COVID-19 coronavirus, with another 160 million infected since the deadly disease first emerged in Wuhan, China, and was spread around the world. The earliest known deliberate burial by modern humans in Africa has been discovered with the body of a young child whom researchers have named Mtoto, which means child in Swahili. A report in the journal Nature has dated Toto's burial in a cave in Kenya to around 78,000 years ago, with the arrangement of the bone fragment suggesting the 2.5 to 3-year-old was buried on its side in a fetal position. Anthropologists found the body was covered in dirt from the cave floor, and it appears to have been rapidly covered, which suggests that it was a burial. Scientists say this burial shows clear differences from those of Neanderthals and early modern humans in Eurasia, providing new insights into the evolution of Homo sapiens in Africa. A new study has found that people are consuming up to 4 milligrams of plastic for every 100 grams of rice they eat, with that number jumping up to 13 milligrams per serve for instant rice. Findings by scientists from the University of Queensland is the first to quantify levels of microplastics in rice. But there is some good news. A report in the Journal of Hazardous Materials found that washing rice before cooking reduced plastic contamination by between 20 and 40%. It's been revealed that the late Prince Philip, the Duke of Edinburgh, had a keen interest in aliens and UFOs. Tim Mendham from Australian Skeptics says the news shouldn't be a big surprise, as members of the royal family have also shown an interest in things like homeopathy.
Apparently he did. The truth can be revealed. The royal family is not particularly well known for being the most scientifically literate. They have been, certainly Prince Philip and I think the Queen as well, have been supporters of a certain amount of alternative medicine cures and things like that, and homeopathy is one of them. But Prince Philip apparently had a big belief in UFOs, aliens, that sort of stuff. He was a subscriber to a magazine called Flying Saucer Review. He had lots of books on extraterrestrial encounters and that sort of stuff, and it was a big thing for him. He used to write to a famous ufologist, and an author named Timothy Good, who described himself as the leading authority on UFOs and alien presence. And Philip wrote to this guy Good that there are many reasons to believe that extraterrestrials exist because there is so much evidence from reliable witnesses. Well, unfortunately, the evidence from witnesses is not particularly reliable, and the sightings and other manifestations are subject to a lot of dismissive debate.
Well, did Philip write to any well-known physicists about this topic? That's what I'd like to know.
Well, it's hard to say because, I don't know that much about Philip's personal life, but I dare say he was in touch with some scientists, etc., but it was often through his equerry, who was his offsider, who might have been his conduit to some of these things. He gave, way back when, this guy the go-ahead to look into any credible accounts of alien encounters or UFO sightings. So it was an ongoing thing for him for a lot of his life. So obviously, the UFO movement really got a boost up after the Second World War and the early 50s, etc., and that's really when he started sort of making a lot of inquiries and apparently sort of having his beliefs.
It's funny because the guy was a pilot. He should have known better.
Well, the thing you find out is that there's no guarantee that people aren't going to believe something. Yes, you would hope that pilots would see more things and be less prone to such things. But, when people keep quoting, he's a policeman, he must know what he's talking about. No, policemen don't deal with aliens very often. Same for pilots. Pilots report seeing things that they can't explain, and that makes it a flying saucer, apparently, or an alien, although followers of ufology hate the term flying saucer. Fair enough.
You can blame the media for that. They're the ones who invented flying saucer.
Yeah, well, actually, the guy who was, what's his name? Arnold was the surname guy who said he saw objects moving near Mount Rainier in Washington State, I think.
Yep.
And that was the source of a lot of the mania. He didn't say. He said they were. Did he say they were saucer-shaped? It was something halfway there, and that was then picked up by the media as saying they were flying saucers, and ever since then that became the shape, the classic shape of these alien craft. Now, you can say unidentified flying object, but that implies some sort of control. Unidentified, yes, object means it is a thing, but flying is a problem. Unidentified aerial phenomenon, which is the UAP, which is one of the other alternatives.
That's the one the US Navy uses now.
Yeah, it's a bit broader, but it can also mean unidentified, up in the sky, and it's a phenomenon. That could be a cloud. Well, the clouds are normally identified, but something you can see way up there that I don't know what it is, but it's up there, and it could be way out in space. It could be Venus. I'm sure all your listeners are well aware of Venus being one of the major things.
Oh, the amount of times
ubiquitous Venus, yes.
Say no, it wasn't Venus. It was definitely not Venus. And I said, you could see Venus then, could you? No.
That is the response. Oh, it was in the way of Venus, was it? Yeah. So, if you look that way, you should have seen Venus. Anyway, I'm sure Prince Philip is now sort of...
Well, he's certainly answered the question now, I think.
He should be able to. Unfortunately, we're probably going to have to wait a while to hear back from him. Apparently, though, he's also his uncle, Lord Louis Mountbatten, was also a bit of a believer in flying saucers. So maybe he passed on the gene.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.